Here we're going to incorporate a bit of sensors. We're going to have XY movements carried out by stepper motors and machine vision by camera. So with the sensors, we're looking at detecting the temperature and humidity. So we use a DHT22 for that. We're looking at the carbon dioxide concentration in the area. We're going to be using an MG811. We also want to measure the light intensity in the room. So we'll be using a BN1750. And finally, a pH sensor to measure the nutrient solutions going through our plants. To moving forward, we also have a machine vision aspect of it, where we shall be able to detect whether the plants are doing healthy or not. This is going to be done by a camera that will be mounted over there, and its movement will be controlled by the stepper motors, moving from one position to another. Yeah, thank you.
From Group B, and I will be explaining the machine vision side of how I generated my code to do plant analytics. So to start off, this is the project that I have in RoboFlow. I have 4 classes. So what I wanted the system to know is if the plant is dead, if it has fusarium, which is a fungus, if it's healthy, or if it's powdery. It being powdery it's a deformation, or it's a deformation of a plant, and it shows that it's not getting all the nutrients that it needs. So these are the different annotations that I have, and these are the different images that I've used. I've used a total of 226 images. So they look up everything from if it's, from if it's dead to if it's healthy, if it's powdery, if it has fusarium on it. And I did all these for the different images. For this, I used both online images and some plants that we obtained as a group to come up with the data set. I have 2 different versions of this because there were some account issues. However, the version that we finalized on was version 2. So as you can see, I've done pre-processing with cropping, resizing, grayscale, the ability to adaptively contrast. I've also done augmentation. So basically, however, whatever orientation this plant could be in, whatever lighting it could be in, this system needs to be able to detect the different classes that I've set it to. And then finally, my data set was created. To import this into PyCharm, I used OpenCV. I used these different libraries. I set the opening parser arguments. I imported the RoboFlow project. This is set to capture the video from port 1, which is where the webcam will is attached to. From the webcam, it gets the width and the height of this part determines the frames. There's some queuing that's put into the frames because there was a lot of lagging. And even when the video is being generated, there is a lot of lag. However, the queuing process, it allows the frame to continuously be read, much as there's a lot of lag, because the resolution of the camera that I'm using is more powerful than the graphics card of the computer that I have. So all of this was done in PyCharm. And when I do run a video, in order for it to not lag, I will use a pre-recorded video, which was once live. So as you can see, as you can see, it identifies if it's healthy, if it's dead, if there's a fusarium on it. However, as you can also see, there is a lot of lag in the video. But all in all, with much as there's that minor setback on the lagging, which would be improved with a more powerful graphics card on my part for my computer, the dataset does load successfully and identify all the different classes that are needed to analyze this plant. Thank you so much.
I'm Joy Masood from Group D, and I did the hardware integration for the farm that is automatically operated. My job was to make sure that the Z-axis is properly controlled and the Y-axis is properly assembled so that the camera is able to view all the plants that are already within the farm. Everything is controlled by the stepper motors and a straight line with teeth on it for horizontal movement, as well as a belt drive with a servo motor over here to control the vertical movement. And to show the demonstration right now, I will have the motors move sideways. As well as vertically. As you can see, the movement is smooth for this prototype. However, it can also be improved later on with a more tight 3D printed component. Thank you very much.
For my part to the group project, I was dealing with the sensors, so I had to code them and initialize them and also connect them to the breadboard and the Arduino where they'll be getting their power supply. So I do run the code using the Arduino IDE, and you can see my results being placed on the serial monitor, starting with the pH and followed by the light intensity in the room. Then you have the humidity, temperature, and the carbon dioxide concentration. For each one of these, I used DHT22 for the temperature and humidity. I used an MG811 for the carbon dioxide. I used a BH1750 for the light intensity, and I used a pH meter to measure the pH throughout the solution.